Good scientific afternoon. We are live on TikTok and YouTube, and today we're going to be doing some more GCSE support, helping you guys out get prepared for your GCSE exams. If you know of people that would benefit from this, please share this to them, and please obviously uh, help everyone out get to this. Now, those on the TikTok account, unfortunately, you're not able to see the live screen that I'm going to be sharing. Um, if you are wanting to see that, please head over to my YouTube channel, which we are live on as well, so that you're able to observe from there as well. And basically, what we're focusing on today is, first of all, cell structure and the different organelles of the cells, because it is one of the key concepts that either any of the exam boards will expect from you. And then, secondly, I want to go into mitosis, which is again linked into cell structure, but a lot of people end up struggling with this because they end up forgetting the order or forgetting what happens in each of these sections. Now, remember, this is getting recorded live on YouTube. So if you know of someone that's busy currently and needs to then watch it at a later time, um, obviously let them know. Thank you for the likes so far. It is much appreciated. And again, um, remember, if you can help me with my goals or help me with any of the other things with my GoFundMe page as well, that would be amazing. This is all free of charge, what I'm doing, but donations are obviously massively appreciated because it will help us continue to boost what we're doing. So, for those on the YouTube live, what you can currently see is both a animal and a plant cell. And the top one is our plant cell, and the bottom one is the animal cell. Now, I've got a question for you all, whether you are on the YouTube live or on TikTok. What three organelles are found in a plant cell but not found in an animal cell? This is GCSE content, but it will have also been taught to you at Key Stage 3. So it is one of them units that is transferred uh, between the two. And can anyone tell me in the comments the three organelles that are found in a plant cell but not found in that animal cell? Thank you for the likes, much appreciated. Um, So the three organelles, the cell wall, chloroplast, and large central vacuole. Yes, El Harley know her. Um, I'm apologising if I've said that incorrectly, but it is exactly that. I mean, we can just call it the large permanent vacuole or just the large vacuole. So, for those of you that are following along on YouTube right now, this one here, this is our vacuole. And as you can see, I've just labeled that now so that it's in place. And as rightly stated on TikTok, we also have then the cell wall and we have the chloroplasts. Now, when we're looking at the organelles, and this is I keep saying this word organelles because this is the language that they use in the exam, and all we're doing is giving the fancy science word to the parts, basically. So rather than saying the parts of the cell, we say the organelles of the cell, just because it makes life that little bit easier. Um, and helps us kind of guide through all this. For those of you just joining, welcome. We're going over some GCSE support right now to help you out with your exams. This is every Wednesday at 5 p.m. and it is free of charge, but obviously any donations are appreciated. So both animal and plants have a cytoplasm, and this is where all of our chemical reactions are occurring, which is a very important part. This is where, like, all of our a lot of stuff is um, kind of suspended, if you will, and found and looked at. And it's a important giftopia. I don't know what that is. I've got no idea. Sorry, things are appearing here, there, and everywhere, and sometimes it's hard to follow. So we've got the cytoplasm on both the plant and animal cells. We then have as um, stated a minute ago, we have the cell wall. Now, the cell wall is always found on the outside of the cell membrane, and the examiners will be that strict if you get the two of them the wrong way round. So make sure when you're looking at your exam paper, you are really focusing on what it's saying in each of the, or where the arrow is pointing at each of the parts. So obviously our nucleus also has a membrane, but for GCSE, you are not expected to discuss this. Now, for those on the YouTube, you can see currently the images that I have, and we're populating it as we're going with our key words. And with this, the nucleus obviously is a key structure to our cells. It is the structure that holds all of our DNA and is what gives the cell the information of what to do. Now, we used to refer to it as the brain of the cell, but we don't refer to it as that anymore because it's not something that the examiners are wanting to see. So we just refer to it as the nucleus. It's what controls the cell and stores the DNA, specifically because it is one of these things where people are able to get confused. Now, another question for you all, welcoming those joining as well. What produces the energy for our cells? So there is a specific organelle that produces all of our energy. Can you tell me what that is? Anyone in the comments, can you tell me what it is? The organelle that produces all of the energy for the cell. And I say all of the energy. In animal cells, it produces all of the energy. In a plant cell, the chloroplast is where majority of our energy is made. Plant cells do also have this organelle that I'm thinking of as well, but in general, it's for a plant cell, it's the chloroplasts, and in a animal cell, it is what we call the mitochondria. Now, the mitochondria, they are a thank you, Pac-Man 1879 for the share, much appreciated. Thank you, Dilku, for the share as well. Thank you for anyone that's also shared and I haven't mentioned. So when it's coming down to the mitochondria were once actually bacteria, and with them being bacteria as well, um, we were obviously, if you go back far enough through evolution, we originally were single cell organisms, and these single cellular organisms um, didn't have energy to become multicellular. Then a bacterial cell known as mitochondria actually entered into a single cell organism, and their waste product was energy. And with that, gave the cell that they actually went into enough energy to start multiplying. And what that did was give them enough energy to actually. Oh, thank you for the love. Um, it is what gave the cell their energy. Therefore, they started being able to evolve into multicellular organisms. And this is how then we are about today because of mitochondria and their part in the evolutionary steps. Um, Now, I just want to pause very quickly just to add a few things to what we're talking about today, is because I completely forgot about this. And for those of you that are on the live, I've got a couple of things that I want to show you. So, first of all, is our new MC Science exercise books that you, or textbooks, no, exercise books, isn't it, for writing in? That you can buy on our website. This is going to be getting given away for free. I'm going to be probably doing a competition next week where you have to answer a question and make sure that you are following and shared it probably to a couple of people. We also are giving away a MC Science mug that we have also got. And more importantly, I'm giving away an MC Science shirt as well. So if you are someone that is very interested in these items as a free item giveaway, obviously please keep sharing and promoting, and please keep an eye out for that competition that's coming very soon, because 3 people will be winning them items. Now, when we're looking at our organelles, so as we've said, the nucleus controls the cell. Did you used to teach at UTC? Yes, I did used to teach at UTC. I left almost, it was about a year and a half ago now, because I, for medical reasons, had to stop full time teaching. And I was back in there for on Thursday for an assembly, and the Thursday before that as well, uh, for the person asking about being at UTC. Um, Now, when we're then also looking at our animal cell, obviously, as we've said, they have mitochondria because they are multicellular organisms as well. Now, when we're thinking, and if I can spell mitochondria correctly for my live, that would be amazing. When we're looking at the energy that they're producing, it is uh, was commonly referred to as the powerhouse of the cell. And again, this is now something the exam boards are not wanting you to be saying. So if you are thinking of in the exam, or you might have done a mock recently and you said, oh, mitochondria, they're the powerhouses, and you didn't get it right. This is because they're, whether you are AQA, Edexcel, OCR, they're not wanting this written in the exam boards anymore. They are solely wanting you to say that it's the place where respiration occurs, or more specifically, aerobic respiration, because we are GCSE. If you were a key stage 3 student, years 7 to 9, just saying respiration is okay. But at GCSE, they want you to state aerobic respiration. Um, And basically, it's the production of energy with oxygen being involved. Whereas anaerobic respiration is the production of energy minus the oxygen. And this is what happens when you get into what we call oxygen debt, which is what you would be doing when you're exercising. And with having a oxygen debt, you end up building up lactic acid in your muscles, and this happens for anyone doing exercise, prolonged lengths. And this is why your muscles might feel stiff after doing exercise, because your body hasn't had time to pay back that debt and break that lactic acid down. So the only way we can break the lactic acid down is by having oxygen present to actually help with this. Hence the oxygen debt. And the final organelle found in both animal and plant cells is called the ribosome. Now, the ribosome is quite a small organelle, but it's extremely important again, which is why they've added it to GCSE curriculum now. And basically, it's where all of our protein synthesis is made. And they use that word synthesis when describing, because the word synthesis basically means making, the making of things. So protein synthesis is the making of. And again, this is where we end up with us using words that we might not normally use from day to day life, but anytime you are making something, you are synthesizing it. And again, thank you to everyone that is sharing, commenting, or giving gifts. Obviously, this information that I'm sharing with you, this support that I'm giving, is free of charge. But again, it is any donations is much appreciated. Now, I want to also add a few other uh, cell types. Now, we've been talking about animal cells, we've been talking about plant cells. So, animal and plant cells are classified as what we call eukaryotic cells, which means they have a nucleus. If you think about it as eukaryotic cells, um, we then have prokaryotic cells. So prokaryotic cells have no nucleus. They're generally bacteria. And again, thank you for those sharing the live as well. Much appreciated. And for those that have hit the like button as well, massively appreciated as well. So bacteria, they have a few differences. Now, because bacteria is so small, they don't have mitochondria inside them or chloroplast, because bacteria don't photosynthesize. But they do have a cell wall because they are single cell organisms. They need that little bit extra strength, which is made of uh, peptidoglycan, not cellulose. And again, they don't have a nucleus. Their DNA literally just floats around in the cytoplasm. So, where our plant and animal cells both have the nucleus with our DNA wrapped up in the chromosome, stored in the nucleus, uh, bacteria doesn't have that. Now, when we then start to look at other eukaryotic cells, we can look at, for example, fungal cells. Now, fungus is different to a plant cell, and a lot of people, for some reason, think that they are both plants, but they actually aren't. They do have a nucleus, just like a plant and animal cell, because all eukaryotic cells do. And their cell wall is actually made out of chitin instead of cellulose, which a plant cell would have, or like I said, peptidoglycan that the bacterial cell would have. And when we're then looking at fungal cells, they can be single cellular or they can be multicellular. And a example of these single cellular would be yeast. And people have yeast. We use it to make bread and things like that. You can actually get yeast infections as well. Whereas when it's a multicellular organism, apologies, um, this would be where we'd have our molds and where we would have our mushroom growing, because they're all connected together. Um, so this is always one of them things that people struggle to get their heads around, is that yeast is a type of fungus. And yes, you do use a fungus to make bread. And remember, it was mold as well, that was first used to make penicillin, the very first antibiotic that we um, had. And I think it was 1923 that that was made. I'd have to double check my notes. And yeah, so mold made our very first antibiotic because we literally discovered it on a dish, separated it from everything else that it was with, tested it on um, bacteria and things like that, realized it killed. And with that, it ended up causing that knock on effect of killing these other things. Um, Now, for those of you also on the live, so I work at part time. I work at Plymouth City College. Give a wave if any of you go to Plymouth City College or are planning on going to Plymouth City College. Hit the like button now. That would be amazing. And hey, Chris, with this, I have started working with students doing work experience as well as MC Science, and they've been helping me film. And for those on the YouTube live right now, you can actually see cheek cells that I took from the inside of my mouth. And we stained them with methylene blue. Um, no, I still go UTC. That's absolutely fine. Not a problem. What year are you now, Chris? Um, and what you can see on this image that I'm currently showing, in fact, let me see if I can just move you guys over here a second, and I will put the different angle of camera. So this, there we go. These are cheek cells from my uh, yes, I remember, Chris. These are cheek cells that were extracted from my own mouth, and with this, this is a GCSE practical that you are expected to do. It's also a what's the word? It's also a key stage 3 practical that would generally get you to do as well in practice for GCSE. But one of the things I want to start looking at um, is expanding the practicals that you do in school. This is a big drive that I'm wanting to bring in because I do strongly believe that practical work is important when it comes to science. Um, used to be in my class. How have you been? I've been brilliant, thank you. How have you been? You got to bear with me. Obviously, it just says Chris on there. I have taught multiple Chris's. I'm trying to remember. what year you would have been in when I left. You would have been a year 9 student. I'm trying to picture my year 9 classes of back then. Everyone misses you. Chris Evans. Yeah. Hey, Chris. Nice to see you again. Um, yeah. Uh, Always a pleasure to see ex students. And with our cells, as you develop from a single cellular organism, a zygote cell, so the very first cell of you, so the haploid, so we've got our two gamete cells, the egg and the sperm. They've come together and made a diploid cell where can you explain how iron's made? Yeah, I could do that in a sec. I'll just I'm learning this in science. That's amazing. Call of Duty love. So we've got the haploid cells, we've got the diploid cells. Haploid cells specifically have half of the amount of DNA. The diploid cells have the full set. So every cell in you, apart from sex cells, are diploid cells. Um, when it then comes to our zygote cell, the first cell that is you and your unique uh, information, um, you end up needing to multiply. And through multiplying, thank you, Jay, for the like. Hope you're getting on well. Um, with this expansion of cells and becoming 2 cell, 4 cell, 8 cell, 16, 32, 64, 128, 256, and so on, 512. Exact, funny enough, multiplication that computer um, memory goes up in. If you've ever noticed the two, so you'll have like a 256 megabyte RAM or a 512 megabyte, and then you'll go up, so on, so on. Glad to hear that, Jay. Um, with this, um, we obviously start to eventually, at the age of about 14 for girls, hit a kind of height cap where you won't really grow much more than the height that you are at the age of 14. And for boys, we carry on generally growing up to the age of 18. Sometimes it will be up to the age of 21. And with this, obviously, there is variability with girls' height development and things like that as well. I'm not saying that at 14, that's it, you're the height you are. They can obviously, it varies from person's DNA, and that's why we call it the mean or the average. And when then we start to look at this, we can then look at what we call mitosis. Now, mitosis is where we make that double cell, and we make two identical daughter cells, basically, from one single parent cell. Now, that parent cell could be the very first cell of your DNA. That it could be the zygote cell that I mentioned a minute ago, which I keep saying that word to you because it is sometimes a GCSE question of when sperm and egg come together, what is the name of that first cell called? And I have seen it on past papers before, and it would be the zygote cell, or it could be any cell. So when you reach your max growing and you have fully developed, you will still need mitosis to occur. Now, you will have either uh, damage, you might have old cells die. You're always getting new cells. Every 7 years, every single cell in your body has been replaced by a new cell. And when you think about that, so I was 37 on the 2nd of March. So my birthday was just 10 days ago. And with this, if we think about it, none of the cells that were in my body 7 years ago are there today and back and back. So the cells that were there when you were first born are long gone, and you've had a 7 cycle. So if you're 14 years old, you've had 2 sets of 7 cycle. At the age of 21, you've had another cycle. So everything that was part of you when you were 14's gone. And then 28, 35. So I've in my 35 year old or above. So at 42, none of the cells that were a part of me when I was 35 will be around. And when you start to think about that, that's quite an interesting thing, because we always have to repair cells continuously. The fastest place in your body for cell repair and replacement is the inside of your mouth, because of the likelihood of infection. Your body prioritizes the healing of the inside of your mouth faster than any other body part, which is why you might bite the side of your cheek and then, like a day or two later, be like, oh, man, where's that gone? It's because your body has replaced it and gotten rid of the damaged cells and replaced it. Now, we have our different stages of mitosis, and I do want to just go back to uh, Raichu Guy. I will go on to ions in a minute if I've got time, and we'll get onto that in a minute for you. So do bear and stay on. So if you're still there now, I don't know if you are, give a wave if you are. And when it comes to interphase, the stages of mitosis, we have interphase, prophase, metaphase, anaphase, telophase, and cytokinesis. Now, cytokinesis and interphase aren't part of mitosis, but we classify them as part of the cell cycle. I will get onto it in a minute. You've asked, and I've here to support. So I will do some talking about ions in a minute. It might be that I end the YouTube, but I'll carry on with the live on here. But I might keep the YouTube going. It's always useful for anyone wanting to watch it later. And so the interphase is where the actual cell is doubling in size. And this is where we double all of our organelles, all of our DNA gets copied as well. And then we go into the prophase. The prophase is where we condense our chromosomes and we dissolve our nuclear membrane. So the nucleus, the membrane that's around the nucleus that I mentioned earlier on, gets dissolved. So now our chromosomes are floating around with all our organelles in the cytoplasm. Then at the metaphase, the chromosomes meet in the middle. So if that's a way to remind her, the metaphase meet in the middle of the cell, and they form like a line across the equator of the cell. Then at anaphase, they have spindles pull them apart, and they get pulled to opposite sides, because we need to make sure that if we're making two identical daughter cells, that we pull the double lot of chromosomes apart, so we know that we've definitely got 23 on one side and 23 on the other. And then we go into our telophase, which is where we've pulled it all apart. We now form new nuclei around the two sets of chromosomes, and we make sure our kind of organelles are separate as well. Then once mitosis is finished, we have to go into cytokinesis, which is where the cells, through like a pinching motion, are actually separated apart, and the large membrane that was created gets turned into two and comes apart, so that we now have two identical daughter cells. And that's mitosis. It's about making multiple daughter cells. Now, I was just asked, as I've said, about the production of, or how an ion is made. Now, I will go over this briefly now, but what I will do is also make it a priority for it to be next week's session. So actually, I'll write it on my whiteboard now. Ions, and I'll go into ionic bonding as well. We'll do a bit of covalent bonding because and metallic bonding all as well in our session next week, because again, they're key bits of information, and it's a brilliant thing that you've asked about this as well, because it's always comes up in the exam papers. So when we're looking at ionic bonding, we can look at, first of all, the group number that the element is actually in on the periodic table. So if it's a group 1 element, it has 1 electron in its outer shell. If it's a group 7 element, it has 7 electrons in its outer shell. At GCSE, they will not ask you about the transition metals. So they will only ask you about group 1, 2, generally group 6 and 7 when discussing ionic bonding, and they don't do any other ionic bonding. Now, ions are formed when a metal, gives its electron from its outer shell to a non-metal. So this requires obviously energy. And so when we are looking at our electron in the outer shell, what we would be looking at is this electron shift. So we're going to talk about sodium, for example. Sodium has 1 single electron in its outer shell. And with having that single electron in its outer shell, what we would then want to do is get rid of it, basically. And this is what why ions are formed, because they want to have a full outer shell. So if we have, and obviously I know I'm talking to you on TikTok right now, but do go over when this live gets posted later today. You'll be able to see the image that I'm talking through as well. So if we had an element like sodium, it's in group 1. It has 1 in its outer shell. If it gets rid of that 1 electron, it will become an ion, because it will now be charged. An electron has a negative charge, whereas a proton has a positive charge. And when any element on the periodic table is on the periodic table, they have the same amount of protons as electrons. So they would have a neutral charge overall. Now, when sodium gets rid of an electron, what we would then have is a loss of negativity, so it would then become positive. So what we would do is draw brackets around that around that element. Hold on a minute. I'm just going to actually redraw my sodium a minute. And we would put brackets around the sodium ion to say now this has a charge. And because it's lost a negative electron, it becomes positive. Now, if this was a group 2 metal and it lost its 2 electrons, it would become 2 plus. And if it was a group 3 element, it would be 3 plus. So depending on what group it is, if it's a metal and hydrogen, because hydrogen is an exception, they will always lose the electrons. If it's a non-metal, they will always gain electrons other than hydrogen because it's the exception. So if I then had the element chlorine, chlorine has 7, it's in group 7, so therefore it has 7 electrons in its outer shell. And like the noble gases, it needs to gain, it wants to have a full outer shell like the noble gases, I should say. And by it gaining one single electron, it would then have a full 8 electrons. So because sodium's getting rid of one, well, our chlorine can have it, basically. So sodium then has a full outer shell, chlorine has a full outer shell, but sodium has a positive charge, chlorine would then have a negative charge. And because then the positive and negative charges attract, this is how ionic bonding starts to actually occur. And this is how ionic substances like salts then start to form. Because we would have these positive and negative ions being formed. So because then the chlorine would have gained the electron, it would have a negative charge overall. And again, if you're following along on the YouTube live, you can see what I'm drawing here. And I apologize about the dot cross diagram. The dots aren't the best, but you know what I'm trying to draw. And because it is a dot cross diagram, we always represent one element as dots, one element as crosses, so the examiner can clearly see what you're representing. And this is what the formation of ions, how it occurs. When it comes to the making of ions, it is that giving and receiving of electrons, which is different to covalent bonding, where covalent bonding, they share a pair of electrons. So they share a pair. Ionic is give and receive. I hope that has answered your question. In regards to this live now, I do want to start coming to an end with it. And I want to just do a few final notes. Again, I want you to keep an eye out. I am going to be doing a competition soon. And to enter the competition, one of the key things is that you've got to be following on both YouTube and TikTok for me. You could win this book or a MC Science mug, or as I said a minute ago, this MC Science shirt. So make sure you are following. Make sure you come along to next week's session, which is when I'll be announcing that competition of how to win one of them 3 items that I'm giving away. And as always, if you ever have any questions about science, DM me. I'm always available to support with any of these things. I am going to be looking at upping the amount of lives I'm doing when it comes to GCSE support, and obviously follow for all of my other content that I post, including career advice, funny jokes, funny memes, anything like that. I like to cover the lot, as well as the support. And if you don't want to wait for my free giveaway, I also do have my shop now live on my website, mcscience.co.uk, where you can buy that equipment. I'm going to end my session now. Thank you all for joining. I hope you have found this valuable, and I will see you all next time. Thank you very much.